Hi everyone, welcome back to PRAKASAM tutorials. In my previous videos, I have designed 7-pole lumped element low pass filter using 4 open circuited stub microstrips. In that videos, I used one design is high impedance line characteristic impedance of 110 ohms with line width is 0.1 mm. So this is the design of the this is the layout of the high impedance transmission line characteristic impedance of 110 ohms, and this transmission line inductor width is 0.1 mm, and its insertion loss or transmission curve is this one. And the second design is same 7 pole lumped element low pass filter using 4 open circuited transmission line open circuited stub. In that design, I used the characteristic impedance of 93 ohms and the line width is 0.2 mm. So this is the second design. In this design, I used characteristic impedance of 93 ohms. The transmission line width is the line width is 0.2 mm. So and its insertion loss at the transmission curve is this one. So now here in this video I am going to design the performance of these two microstrip filters, that is design 1 and design 2, and the design 1 is 110 ohm high impedance line characteristic impedance and the line width 0.1 mm, and the second design is characteristic impedance of 93 ohms with line width is 0.2 mm. So the performance of these two microstrip filters is, is shown in this figure, and this is design 1, this curve, and this curve is design 2. So now import design 1 here. So the design 1 is already design 1 is written loss curve already saved in my laptop. So import that results into design 2. Right click on this graph, go to import, select that parameter design 1 7-pole lumped impedance 4 open circuited low pass filter. Okay, now here this green color curve is the design 1. So design 1 means 110 ohm characteristic impedance, line width is 0.1 mm, and this red color curve is second design, and that second design characteristic impedance is 93 ohms and uh, line width is 0.2 mm. So now here observe these two waveforms. As can be seen, the two microstrip filters have not only differently from the lumped element 1 but also differently from each other. So the main difference between these two lines in the stop band behavior in the design 1. So this is the design 1. In design 1, stop band okay. The main difference in these two designs, stop band behavior, and this is the design 1 curve and this is design 2 curve. The microstrip filter, that is design 1, that design uses narrow inductive line. So what is that narrow inductive line with 0.1 mm has a better matched stop band performance. This is because the use of the inductive lines with higher characteristic impedance and a shorter length to achieve a better approximation of the lumped inductors. And the second microstrip filter design, and this red curve is the second design. So the other microstrip filter, that is designed to with the wider inductive lines. So this wider inductive line width is 0.2 mm, so which exhibits an unwanted transmission peak and this is unwanted transmission peak at 2.87 gigahertz. So the unwanted transmission peak at 2.875 gigahertz, which is due to its longer longer inductive lines being about half wavelength and resonating at about this frequency.